Notice, by the way, when I take a look at the reflection over the x-axis, the graph y equals negative f at x is a reflection over the x-axis, and really its effect is it keeps all of the x values the same, but it negates the y's. Like we talked about in the previous example, a previous section, this negative is appearing outside or away from the original f at x, and so since it's an outside change, it affects the y's. So the x's stay the same, the y's get negated. Outside changes affect the y's, not the x's. So now let's take a look at reflections over the y-axis. So I'm going to take a look at what happens if I do g at x is f at negative x, where now the negative is on the inside of the function. Just like we mentioned before, a negative or a change outside the function affects the y's. This is a change inside. We're going to expect it to change or alter the x's. So again, let me use my f at x is 2 to the x function. Again, I graphed it, same function I started with the last time. But now instead of doing the negative out in front, I'm going to do the negative in the exponent. So I'm going to do f at negative x, which takes out the old x and puts in a negative x for the new one. So if I do that, and I were to take a look at the two tables, what I would notice has occurred here is I basically have kept all the y's, but I've just taken the x's and negated them all. This has just negated all of the x's. It's kept all the y's, I've used the same y values, but it's negated the x's. So the graph of f at negative x is a reflection of y equals f at x over the y-axis. All it does when I have the negative inside is it keeps the y's. Inside changes keep the y's the same, but they affect the x's. And in this case, what it does is it negates the x's. So f at negative x negates the x's, keeps the y's.